move that inside the different integrals and so forth, as we will see later on. Okay, but if we look at what's inside the expectation operator here, we have something which is random and something which is deterministic. The energy per pulse, EH, the energy for H is not random, it's what it is. However, the amplitude varies, so that's what's random here. So we can write this as the energy per pulse, EH. We take that outside, and then we have the expectation of the magnitude of A0 squared. Okay, good. So what can we say about this? Well, now we just have to use the rules for expectations in order to figure out what this is. So we continue up here and we write this as EH, and then to compute the expectation of something, since it's a discrete random variable, we talk about the sum here, otherwise it's an integral. So it's a sum over all possible outcomes of A0. Okay. We know that A0 takes on values in the set curly A, right? And all of these are equally likely, but by definition, it should be the sum from, let's take a variable m equals 1 to capital M. So it's a sum over all possible outcomes of A0. Okay, and the outcomes is then AM magnitude squared, and the magnitude squared here becomes the magnitude squared here. So it's a function of A0. So A0 could be A1, A2, A3, capital A1, 2, 3, etc. Okay, and then the probability, this is multiplied with the probability that A0 is equal to that particular amplitude. Yeah. Okay. So here we just use the definition of expectation. Good. And now we use our simplified assumption here that we know that the probability that A takes on a certain number here is just 1 over m. So all of these probabilities here are just 1 over m. Okay, and what we end up with is EH times 1 over m, sum small m from 1 to capital M over AM, capital AM squared, like this. And in a way, this is the average squared amplitude in our constellation, right? So this is a constellation point. We take the magnitude squared of it. We add all those together and divide by the number of points we have in the constellation. So it's the average energy for that constellation. So this is something that, by definition, we call the average energy in the constellation. And to be consistent with the notation in the book, it's a subscript A here. Okay. Questions so far? Okay. I think we take a break now for 15 minutes. I took 4 minutes here. So let's reconvene 19 minutes after the hour. Right? Kan du stänga av den och trycka på den röda knappen?